Okay, last one. So we have the base of a solid, happens to be the region bounded by the equation y equals x squared and y equals 4. If the plane cross sections are perpendicular to the y-axis, this is definitely new for us, then we want to find the volume, especially if we're using squares. So if we're perpendicular to the y-axis, when we draw it out, you'll see that that means we're going to integrate with respect to y this time. Takes a lot more for me to write this out. And of course, if we're squares, area formula for a square is side squared. So let's get a picture going of what we've got going on here. Y equals x squared is pretty simple. Y equals 4. 1, 2, 3, 4, even easier. So we know y equals x squared is 0, 0. 1, 1 on both sides. Hey, 2, 4. Perfect. So we're going to take this region right here that happens to be bounded by that y equals 4 and that x squared, and we're going to place squares in them. But our squares are not going to be perpendicular this way this time. Now they're perpendicular this way. So we can see, if you can imagine, all of your squares are stacking up. The smaller squares will be here, and the biggest square will be on here on the back. So since they're going perpendicular to that y-axis, we're going to be integrating with respect to y. If we're integrating with respect to y, we have to have our equation solved for x. So take the square root of both sides. Again, it sets up plus or minus that square root of y. So our right side would be the positive square root of y. Our left side would be the negative square root of y. So our volume. Again, since we are integrating with respect to y, we're going to look at the y values. In this case, we go from 0 to 4. Our formula, again, it happens to be that side squared. We just have to get side in terms of x. Again, our square goes from this side to this side. So just like our area under the curve or area of a region, we're going to, instead of doing top and bottom, we're going to do right curve minus left curve. So our side is controlled, and its width is controlled by the square root of y minus the negative square root of y, which means the length of every side is 2 square roots of y. So I go to my volume formula, I can plug that in. Oops, not dy up here or dx, it's dy. Simplify before I integrate. So that's going to get me 4y dy. Ridiculously easy to put into my calculator at this point in time, or even easier to do an antiderivative from 0 to 4, which this really just becomes 2y squared from 0 to 4, which you should get as 32. So again, the whole idea behind all of this is just being able to figure out, what are you integrating with respect to? What is the length of the side of the figure that you are trying to find? And do you know the formula for that basic geometric area?